All right, we are going to learn about the chain rule today. But first, I have 3 anticipatory set do now problems for you to do. In a moment, I'm going to ask you to pause, but I want you to find the derivative of this guy using product rule. Number 2, I want you to find the derivative of this one using quotient rule. And number 3, I want you to find the derivative of this one using quotient rule as well. So I would like you to pause, and then after I hit play in a moment, or after you hit play, after you've done it, the answers will pop up for you. So go ahead, hit pause, do all 3 of these. Here come the answers. Okay, I've got some answers up here for you. Whoops, I forgot to box this one. First one should, I think you should be pretty good with. Maybe you forgot to simplify, but we get 8x to the 7th times ln of x plus x to the 7th, and you can leave it like that. The next time I'm going to use quotient rule, so I wrote quotient rule out here just to make sure I didn't forget it. And then I color-coded this for you. This is the high, this is the low. So it's low, and then d high, so the derivative of the green over here, minus high tan x, d low is the derivative of this, over low, which simplifies to this. I think that the most common spot to make a mistake here would be to write an x to the 11th instead of x to the 18th. That's a mistake that people frequently make, but I think I can convince you quickly that it's supposed to be x to the 18th. If I had 2 to the 5th cubed, it'd be 2 to the 5th times 2 to the 5th times 2 to the 5th, because that's what it means to cube something. So that means that you have 15 of them there. So it is 2 to the 15th. So my rule is to multiply. 2 times 9, 18. Hopefully you're okay with that one. The next one is I use the same color coding system. So it is low and high. So low d high minus high, then the derivative of the low. This 2x and those 2x wind up being the same things, but that's because these both have x squareds in them, over low. Now, I do want you to simplify this type of problem. So you would go like this. You would FOIL, or you would distribute the 2x's in. Gives me a 2x cubed and another 2x cubed, but one's positive and one's negative, so they go away. And then I've got this, and it brings me down to negative 18x. It's good to simplify those things because this is a easier form to use for when we need to use it later. All right, so hopefully you're good with some of those previous rules, and now we are going to bump into our ideas around chain rule. All right, so before we do chain rule, I want to point a couple things out to you of things that are similar to chain rule. So the first one, and these will tie into the way I'm going to teach you chain rule, is I want you to find the derivative of x to the 5th. So find the derivative for x to the 5th. Prime that thing. It's easy power rule. You should get 5x to the 4th. Next one, find the derivative of sine of x. Maybe I'll throw it in brackets, prime. Find the derivative with respect to x of sine of x. Go ahead, write it. Okay, you should get cosine x. Okay, so now we're going to do x to the 5th times sine x. I want you to find that thing's derivative. What rule do we use? Product rule. Go ahead and pause for a moment if you need to. Okay, here comes the answer. We get derivative of the first, which is 5x to the 4th, times sine x. That one doesn't change. Plus the derivative of the second, which is cosine x, times the first, x to the 5th. And once again, we don't like writing it like that because it's confusing. So it's 5x to the 4th, sine x, plus x to the 5th, cosine x. And it's totally fine for you to skip this step if you can remember to reorder them as you're doing them. So the reason I do this is because I want to point out to you that this right here is product rule. You should see that. So what chain rule is a little bit different. So I'm going to just show you how to do it because I think that's the easiest way to learn how to do chain rule. So example 1. And I'll explain what we use it for with the example. So say I've got y equals sine of x to the 5th instead of instead of one of these three up here. Notice this was x to the fifth, this was sine x, and this was a product of those two. So in this one, I've got x to the fifth, but it's interior to the sine function. So in this case, I use chain rule, and I'm going to show you exactly how to do it. So the way we do it, this is the inner function, x to the fifth. So what I'm going to do, y prime equals, all right, we do the derivative of the innards. That is 5x to the fourth. That's just power rule on this thing. It's what we did up there a moment ago. Then we multiply it. So I'm going to show you what we multiply it by. You need to think of this sign right here as being sine of, right? Sine of what? I don't really care. What would the derivative of sine of be? Well, it would be cosine of, right? Didn't we just do that? Sine of x derives to cosine of x. So what we're going to do is multiply here by cosine of, right? And then the question is, what becomes the of? Well, this piece right here, this piece right here slides in there. So I get x to the fifth. And that's the chain rule. I do the derivative of the innards, which would be 5x to the fourth, that's this thing derived, times cosine of the original innards. Where's the cosine come from? It's the derivative of the outer layer. So let's do another one. Let's do example 2. Let's do y equals sine of, no, sorry, not sine of, sorry. Let's do cosine of, and then I'm going to make my innards x cubed plus 1. Why don't you pause this and see if you can do it based on what I set up there. Okay, I'm going to just tell you the answer and then I'm going to walk through it. The answer is negative 3x squared sine of x cubed plus 1. If you got that, awesome. If not, then just hang along and you'll be able to get it very soon. All right, so what do we get? Y prime equals. All right, what is the inner function? That is x cubed plus 1. What is the inner function's derivative? Oh, I can do that. It's 3x squared, right? Because the 1 there derives away to 0. And then I'm going to multiply it by, all right, what's my outer function? Cosine of. What does that derive to? Well, that would derive to negative sine of. So I got times, and I have to throw a parenthesis in here to deal with this negative correctly. So negative sine of, and then what slides in the of? This thing, x cubed plus 1. So when I reorganize things, I just put that negative out front. I get negative 3x squared sine of x cubed plus 1. Hopefully you see that. Let's try another one. Let's do y equals tangent of x to the 8th. If you want to pause and try it, go ahead. Okay, here comes the solution. Y prime is, all right, what's the innards? X to the 8th. What's the derivative? 8x to the 7th. Then what's my outer function? Tan of. Well, last time we did the derivative of tan of. It is secant squared of. So I get 8x to the 7th times secant squared of. And then what goes in the of? The original x to the 8th. And this one doesn't really have to be changed at all. There's no negatives, nothing messy. I can just leave it just like that. Okay, the next example, I think you should probably let me walk through the whole thing because it's a little bit different, but it helps you really see what the chain rule is. So this is example 4. Let's do y equals sine to the 4th of x. So with this one, I always tell people that you want to rewrite the function before you take the derivative because it makes it a lot easier to see what the inner function and the outer function is. It also makes it so you don't miss the chain rule. So this is equal to sine x times itself 4 times. So that's what sine to the 4th of x means. It means sine x and then raise it to the 4th power. So in the previous ones, I had like an exponent piece, a polynomial piece, as my innards. You should see here that I now have a sine of x as my innards. So when I take its derivative, my y prime is equal to, then I need to do, that is what I typically call it my chain rule piece. The derivative of sine x is cosine of x times. Now this is where it gets weird. So I like to think of it as, up here I could say tan of secant squared, or tan of derived to secant squared of, cosine of derived to negative sine of, right? But here, I like to think of it as to the 4th. And what does to the 4th derive to? It's just power rule. It derives to 4 cubed, right? So that is the equivalent of this piece right here. The derivative of the outer layer of this to the 4th is 4 times this cubed. So I get times 4, open bracket, close bracket, cubed. What slides in there? My original innards, which was sine x. And then this should be rewritten in 2 ways. One, bring the 4 out front, write the cosine x, and then that sine of x cubed, I can convert it back to the way the original problem was given to me and write sine times sine cubed of x. And that's the correct answer for that one. Let's have you try another one that's just like that. Let's have you do example 5, which is going to be y equals cosine to the 8th of x. So go ahead, hit pause, and try the whole thing out, see if you can get to the end there. And then I'll do the whole thing when it's paused for me, so the whole solution will pop up for you. So hit pause, see if you can find the derivative of cosine to the 8th of x. Okay, well, bam, cosine to the 8th, rewrite it. This was the first thing I wrote, negative sine x, because it's the derivative of the innards. Then I came over here and I wrote to the 8th. I derived that to get 8 to the 7th. So that gave me the 8. I left this blank to the 7th, and then I slid my cosine in, and then I rewrote it. I don't know if I said the negative earlier, but I get my negative 8 sine x times cosine to the 7th of x. And that's it. That's the answer. Let's do one more. We're going to do example, what is this, 6? I'm going to do y equals secant of e to the x. Now this one's funky for a couple reasons. One, e to the x derives to e to the x. So y prime is, when I do my inner chain rule piece, I get a e to the x. Next, secant of derives to secant of times tangent of. So when I do my ofs, I get e to the x times secant of times tangent of. But then what needs to slide in? I need to slide my e to the x in for each part of the chain rule. Because unlike the previous ones where there was only one piece in the derivative, this one has these 2 pieces. So hopefully that's good. I'm going to give you a couple more in another video. You're all doing a great job. Thank you.